All right, everyone. Thank you so much for being here tonight. It's the November issue of the Applied AI Meetup Group. And tonight I'm thrilled to have Stefan Krawczyk join us. He is the creator of an open source Python microframework called Hamilton. And as I was saying earlier, I saw him do this presentation at a AI camp, and I was really blown away by the power of this open source project that he built. And so I asked him to be on the podcast, which will be out next week, and then also to present. And he graciously accepted for this. And he'll get into, of course, in depth with regards to what Hamilton is, but in general, it enables a simpler paradigm for data science and data engineering teams to create, maintain, execute, and scale code for feature and data transforms, especially when there's a chain of them. And I'll be posting links along the way. If you went to the Meetup page, you'll see a link off to the open source project. But I'll be posting some links not only to the project but also to Stefan if you want to connect with him, of course, afterwards. We are recording this, so we'll have this up on the YouTube page as well. And please let people know about it and get people to follow our channel. Before I hand it off to Stefan, just a reminder to the Applied AI conference is tomorrow. We'll be starting bright and early at 8 a.m. and it's here in the Twin Cities. And it's an in-person conference. Details are at appliedaiconf.com. And I'm pretty sure most people that are on here have already signed up, but just wanted to let you know, if you have somebody else you think that would want to go, please go ahead and share the link that I'll post. We have a special discount code for people that are a part of the Meetup group. And friends of the Meetup group are certainly open to use that code as well. So you'll see that in the chat as well. So hopefully we'll see you there tomorrow bright and early. And also, this group meets the first Thursday of every month. So our next meeting is December 1st, and I'll be posting a link off to the presenter for that month. We're going to be talking about AI and like the metaverse. It's going to be a really cool conversation. So please come back next month if you can as well. Again, like I say, Thursday is the first Thursday of the month at this time. So I will hand it off to Stefan and take it away from here. Thank you, Stefan.
Cool. Well, thanks, Justin, for having me. Excited to chat to everyone about Hamilton, which is open source Python micro framework for data or feature engineering. In terms of questions, interruptions, like maybe place them in the chat just so I can read them, and then I can also if I want to answer them later, I can also come back to them. So if you do want to interrupt, I guess put questions in the chat first, please. But otherwise, if I'm going too fast or my accent is a little hard to understand, don't be shy to also make me repeat myself. But with that, I'm just why don't we get started? So in terms of just for like roughly the next 45 minutes or so, I'm trying to kind of talk about Hamilton, and convince you that it's a kind of new paradigm to create data frames. Now, it's not only, as I'll kind of mention in the talk, for creating pandas data frames. You can kind of create any Python object, but largely most of the examples are going to be pandas based. The other is that the team at Stitchfix, or teams at Stitchfix who use it, it's a productivity boost for them. And otherwise, just a reminder, as Justin said, that this is an open source project. We have a Slack group that we're also curating. So if you want to find out more, find us on GitHub or join Slack. So first, before saying what Hamilton is, I'm going to give you a little bit of the backstory of like why it was created. So in terms of at Stitchfix, there was this forecasting, estimation, and demand team, or Fed team for short, and they were a team of data scientists that were responsible for helping the business actually kind of decide what staffing levels should they have and when should they have them based on customer demand and seasonality, etc. And it was one of the oldest teams at Stitchfix, and so their basic workflow looks something like the following. They got business actuals, say marketing spend, number of signups, other things that happen. They then kind of created a featureized data frame. So took these raw inputs, translated them into something that then they wanted to kind of fit some time series models with. That these models predicted the future, and then they gave the company a forecast with which to make decisions with. So what was happening was, since they were like, the business needs to make decisions, but unfortunately their pipelines were kind of on fire, and so in which case they're kind of under the gun and they were kind of under a lot of stress. And so I was part of a team at Stitchfix who was essentially engineering for data science. So I was, tasked with, I thought, let me see if I can help. And so in terms of this pipeline, the biggest problem was actually in managing and creating this featureized data frame. And this is what, why we created Hamilton, was to initially help solve this initial pain point. And you might be wondering, why was this kind of creating this data frame, like, causing them so much issues? Well, if you think about it, the data frame or the table that they were creating was thousands of columns wide, and it wasn't, you could say, it's thousands of weeks long, but, this wasn't big data, so everything fit in memory. So, and specifically, the reason why there were so many columns, so if you're familiar with time series forecasting or not, it's one of the domains where it's actually really easy to create a lot of different features or derived features that then you use to kind of, fit time series model off of. So a lot of these columns or in this table or are basically functions of other columns. And so you then can kind of build up as this kind of chaining that happens. And this is really where, the size and complexity of what they wanted to build off of and create models is really causing them a lot of pain. So just to give you an example, just to project a little of like what this code kind of looked like. So essentially you can think of it as like there was this giant pandas script. Where, at the top of the script, you load the actual data, goes to the database, goes to the data warehouse, maybe does a query, pulls in some actual data into memory. And then the rest of the script is essentially kind of adding columns to this data frame. In terms of, you can kind of see here that, there's a lot of, maybe you delegate some parts to a function, maybe there's a lot of one-liners, because, pandas, you can do really, powerful things in just a single line. Maybe they wrote functions. Maybe there's some comments just to roughly say what's what, but they're not very extensive. But essentially, I want to say this code looks innocuous, but scale this to 1,000 columns and a growing team over 5 years or 10 years, I guess, at Stitch Fix. And so kind of the reasons why is that why was this a pain? So when you have a script where a lot of different functions are done, or feature transforms are done in a lot of different ways, you have a lot of different ways of defining or doing the same thing, in which case managing this code base means you get a lot of kind of sprawl and people just basically cutting and pasting. So there's a nice structure to it. Inline data frame manipulations are kind of are great, but they're hard to unit test because they're not in functions. So to test anything that you add there or change, you need to run the entire script, and that gets longer and slower as things go on. You need to understand kind of the code ordering between things, because if you change something up at the top of the script, how do you know you're not going to impact something down the bottom? It's not obvious without you really knowing the code. And then otherwise, writing and appending to a large script, isn't the nicest thing to kind of manage or walk into as a new person to really understand what's going on. So in effect, just to summarize, it's like, there isn't much of a unit testing story, because it's, everything's in one-liners or scripts or functions that may or may not be, well tested. Documentation is tough because you can't really, there isn't a natural place to put it there. And then, this impacts, just how the code is structured, code reviews. How do you know if someone, if they change something, what its downstream impacts are? You really need to kind of understand the code base. And so this then directly translates into, longer onboarding times for people joining the team. And also subsequently, like, well, if you want to debug something and understand why you got an output, you really got to understand the entire script to know like what possibly could have changed or what touched it, etc. So in short, the code for featureization was really kind of what the issue was. So on to Hamilton. So with that motivation, we built out Hamilton. So the way that I could describe Hamilton in a single sentence, it's a declarative data flow paradigm. So it's a paradigm, so it's a different way of thinking, gets you doing things. It's a data flow paradigm, meaning you describe how data and kind of compute go together. And then it's declarative, as I'll kind of explain, but it essentially gets you to kind of declare what you're outputting, and then also explicitly declare what inputs are required to kind of compute something. So at a high level, with Hamilton, you write code that kind of represents this data flow, so how compute and data should move. It then kind of creates a DAG or directed acyclic graph, which then outputs an object. So user writes some code that then you give to Hamilton. Hamilton instantiates this as a directed acyclic graph, so we know the dependencies, kind of how things should flow. And then you as a user, from the superset of what all possible things that you could do or compute, tell Hamilton to compute a result and get an output. So in which case, a pandas data frame, if that's what you want. in terms of, just to kind of, the reason why I say it's a new paradigm, well, it's because you write these declarative functions, right? So rather than having this procedural code of, creating column C from summing A and B, you rewrite things as functions, where the function name is kind of an output you can get. So in which case of creating pandas data frames, a function name corresponds to like a feature name or a column you can get out. And then function input arguments then therefore declare, its dependencies, what's required as input. And so from that, we can kind of, so to compute column C here, we'll know we either need to find another function called column underscore A or column underscore B, or expect them as input. And then from there, we can kind of, build kind of nodes as edges, and that's how we build this directed acyclic graph. As a bonus, we can, do some simple static type checking to ensure that, nodes, outputs of one function can, are valid inputs to another. So we can use the type hints. And then one nice thing as a byproduct of doing everything in functions, that we have a very nice spot for documentation. So there really isn't any excuse for not being able to provide some if you need to. So in terms of just to kind of ground it with some actual code, what I just said before, so instead of this kind of procedural code, you declare everything as functions. Now, these functions, though, as some of you might have caught on, like you can't execute these directly. So we need some driver code, which I haven't shown just yet. But in terms of just to hammer home what I was saying is, so to create column C, we define this function C, and then declare its dependencies as A and B. And then to produce D here, we define a function D and declare C as its dependency, because that's the only thing that depends on to compute things. And that's really kind of like the paradigm, the mind shift you need to do is rather than writing this kind of code, you need to write procedural code, you're writing things as functions. So full hello world looks something like the following. What Hamilton forces you to do is actually, decouple these functions and data flow from where you're running it. So you got to put your Hamilton functions into some sort of Python modules, and then you got to then write some driver script to actually say what you have to execute. The driver script essentially just has you import a Hamilton module, and then you import your function logic to so in this case, if it's called feature logic.py, then you just import that. You then instantiate a little Hamilton driver object that takes in maybe some configuration and initial data, but then you pass it the modules you want Hamilton to crawl to build this kind of DAG from. You then, with that instantiated, you can request what you want to be computed, and then Hamilton will go compute a result for it. So in short, for every equality statement, you're writing functions. These functions declare a data flow, and then when you give it to Hamilton, Hamilton creates a DAG. And then Hamilton handles DAG execution. So you go from functions that declare a data flow, provide them into a driver that will then build this kind of DAG. You then say what you want, and then Hamilton, since it knows the structure, will figure out only to walk the nodes or walk the graph for only things that are required to compute what you requested. In terms of, why is Hamilton called Hamilton? One of there's the two things that are the two hardest problems in computer science. One is cache invalidation, the other is naming things. And so I feel pretty proud of at least why Hamilton is named the way it is. So as I mentioned before, the team we're kind of building this for is called the Forecasting Estimation Demand Team, or FED for short. And I was thinking, this was something very foundational for them that they're going to use. At the time, I had just gone to see Alexander Hamilton the musical, so I was like, oh, I know who the father of the Fed is, Alexander Hamilton. And then the team itself is trying to model business mechanics, so it can provide forecasts for the business. So in physics, they're Hamiltonian concepts, and they're also doing some graph theory here to translate and actually do stuff. And so there's also Hamiltonian concepts there. So in which case, apropos Hamilton. So in terms of just to I described what it is. So what does some actual code look like? So with Hamilton, one of the things that kind of I think strikes me is that we can make an entire kind of set of transforms look pretty uniform, since because you're forcing things into functions. You are required to kind of type annotate them. And you can kind of, I guess, see from here, sure, it might be a little more verbose than these kind of one-liners that you have with, if you're writing things in the script. But otherwise, the trade-off there is that we always have, space for documentation, and as I'll get to, a few other nicer properties as well. But specifically in terms of the way to kind of read this is that, the name of the function is something you can output, and the function input arguments, specify, what's required to compute this. So when you're, if I'm creating a new function, you just need to know what you want to call it, and then, what exists so that you can kind of declare input dependencies on it. In terms of, the driver code, it isn't anything complex, just to walk through a more extensive example. You need to kind of either provide some configuration or some initial data to tell Hamilton, what to construct the DAG from, or to provide data's initial inputs to the DAG. You then got to like import where your logic or your data flow functions, Hamilton functions are defined. You're instantiating this object. And then, asking for things to be computed, and then, Hamilton will only walk the DAG for what's required. The bonus thing with Hamilton is that from a documentation perspective, we can also, provide a graphviz kind of rendering of what's actually going to be computed. And so we have, a few more functions here that you can kind of, customize if you want to, if you know graphviz, we kind of allow you to customize a few things. But as someone who's getting started and more of a visual person, with Hamilton, it's easy to kind of provide someone a visual representation of what they're getting themselves into. In terms of implications for your code base, so as I mentioned, so you write Hamilton functions into these modules, and then you got to write some JavaScript. Hamilton, just to hammer home, forces you to curate things from the beginning. So you're never appending to a script. You're always forced to, if you want to write a function, you got to place it into a module. So then it forces you to really, think a little more carefully. It's like what you're doing and where you're grouping. And then because you write these things to these functions into modules, you then have to write these driver scripts. And the nice thing is that these driver scripts are decoupled from these functions. So it's actually very easy to kind of maintain and have different drivers for different contexts. So in short, with Hamilton, rather than you cutting and pasting code, it forces you to curate things to modules. The benefit is that, your modules are, enable reuse from day one. And then, as I mentioned, it's very easy then to support different contexts reusing kind of the same logic. For some of you, you might see similarities to like maybe is this Airflow replacement? Is this a prefect or another kind of replacement? I want to say so Hamilton is not a fully fledged orchestration system. So it doesn't replace using Airflow, Metaflow, Kubeflow, pipelines, etc. It's really trying to help you model the micro of what you're doing versus the macro that these kind of larger orchestration systems are trying to take care of. And so instead, like what happens at Stitch Fix is you typically use Hamilton within a step of your ETL, or within multiple steps of your ETL. And that's one of the reasons why I call Hamilton a micro framework, because you kind of embed it in all these, basically anywhere that runs Python. And then just to kind of hammer home the point, so Hamilton got its roots in feature engineering, especially around pandas, but you can model any Python object creation with Hamilton. So if you wanted to model your full end-to-end machine learning workflow, you can do that with Hamilton. Or if you want to model any Python object creation, you can do so with Hamilton. But just for the rest of this talk, I will anchor on pandas. But by no means, if you read the docs, don't feel that you're limited just to pandas. And so it's really easy to get started. Pip install SF Hamilton, hello world, you should be up and running easily in less than 15 minutes. Otherwise, we do have docs on Gitbook. So if I was to summarize or take over what Hamilton is, so it's a declarative data flow paradigm where the key is that you write these declarative functions where through the name of the function and then function input arguments, you describe a data flow. And then you have to write some JavaScript so that will where you kind of express what the DAG is and then what you want to kind of run and execute. The net result is you don't have to manage these monolithic kind of scripts. Instead, you're managing transforms that are very kind of easy to maintain, and then driver scripts for your particular context. So Hamilton at Stitch Fix. Hamilton, I guess we open sourced Hamilton last year, and I guess now it'll be actually closer to 3 years that Hamilton's been running in production at Stitch Fix. And so, the teams who use it at Stitch Fix really like it. Specifically, I talk about the Fed team in particular. So as I mentioned, the goal was to how can we help them manage and wrangle the code base? So specifically, can we increase the ability to test their code, be more test driven about things? Can we enable better documentation? And actually, can we also just improve the ergonomics of the development workflow? And so just by, rewriting things into this function, I want to say, we actually, checked all these boxes. And actually, I want to say we actually hit it out of the park. So why was this a home run for, say, the Fed team? So from the testing and documentation perspective, so Hamilton, like we actually push you to try to, compute things once. So there is no going in like, mutability of columns, like that's a kind of an anti-pattern. So with Hamilton, it's actually pretty easy to, like, if you see an output, the name of the column, find that code so that you can, understand what it is. So it's very easy to go from output to where the logic lives. Therefore, there's only a single function that needs to be tested. And then the function signature, just because of the way that we've kind of described things, you haven't actually, it's very easy to write a unit test for this. And then similarly, just because as I kind of we'll get into that, because of the fact that you have to stitch together things through the naming, it actually forces you into a better naming scheme of things. You won't find foo bar in a production code base at Stitch Fix. All the features and things actually, maybe a slightly more verbose, but they're super easy to understand what they are. And then just because we're using functions, things naturally come for a place with documentation. And so, everything is naturally unit testable. So if you want to be test driven, Hamilton is a perfect, paradigm for you. And similarly, everything is naturally documentation friendly, since you always have the function doc space to actually, write something that isn't going to get in the way of reading code. In terms of the workflow improvements, so Hamilton also enables you to easily visualize your computation, as I kind of mentioned before. It actually and also enables faster debug cycles, a better onboarding and collaboration kind of setup for like pull requests. And as a bonus, as a byproduct, we at Stitch Fix for the Fed team in particular, they kind of end up creating the central feature definition store. And I'll get into that, what it is. So from a visualization perspective, as I said, with Hamilton, you can kind of visualize things. So if you were to manage 4,000 feature transforms, that's probably seems pretty overwhelming. But if you could visualize them, or at least, if you're trying to understand what one is, it's very easy in Hamilton to kind of, do that for you. We do, export things into a .file format. So if you do have other visualization packages, you can kind of, export that and like maybe understand the dependencies between things more easily that way. In terms of debugging functions, say we needed to debug spend shift 3 weeks per signup because we saw in the output something's funky, maybe there's some nans in there. Well, we know that the output maps to a name of function, so we know the place to go look at. But then from a debugging standpoint, we either know that the logic, the bug is either in the logic here or within its upstream dependencies. And what is upstream dependencies? Well, they're very clearly and easily defined such that if we were to debug this or figure put a debug statement here and it wasn't this logic, then we'd know that, oh look, we just need to recursively go back up the dependencies. So debugging is actually very methodical and procedural here with Hamilton. And the other nice thing, byproduct of putting all your logic into modules, is that it's actually really easy to then if you want to further debug or even, a prototype and develop, you can actually, import this module as a kind of library and, play around with it in your REPL. In terms of collaborating on functions, so it's easy to impact changes when the names mean something. So if you get a pull request and someone wants to change the name of something, you would know that, oh look, okay, have you changed the downstream dependencies? It's very kind of the things to look for in a pull request are pretty straightforward, right? If you want to add a new input, that either that you have to name something a new output with some name that doesn't clash. So then that you're not going to step on anyone else's toes or any other inputs. If you change the name of function, like I mentioned, or rather, so if you add a new input to a function, it's very clear what you're doing. Like, oh, you're adding a new dependency. So then it's also very easy to understand, the upstream impact, also the downstream one. Similarly, code usually lives for a long time. People don't know if things are used. Well, with Hamilton, you can actually at least, search the code base, understand whether someone's using something or not pretty easily. And so as a consequence, Hamilton, enables a faster kind of, pull request cycle. And then from an onboarding or handoff standpoint, you can, it's pretty easy to pick up where others left off, just because you have, the name of the function and kind of input arguments and doc strings to kind of help you there.
Guys doesn't work.
Justin, I think I can hear you. In terms of a Stitch Fix central feature
Sure.
definition store. This was a nice
Sure.
byproduct of using Hamilton, right? In terms of how they used it, so the team essentially had to, came up with their own kind of convention. So specifically, say for in time series forecasting, there's this kind of you basically create subgroups of features, and so they basically rather than saying date underscore something, they came up with a little prefix to say any feature that has d underscore means it's a date feature. And then along with that, they also organize them into thematic modules, and so this meant that also if someone was developing or adding new things, it was actually very easy to isolate what they were working on and like understand where it kind of fit in the data flow, or like what they wanted to create. And then the other thing is with Hamilton, because we're actually writing code, and if you couple this with a version control system such as Git, it's actually then really easy to kind of understand the state of the world, or like what was computed last month from today, because you can just look back in history with Git. And so if there is ever any like, hey, how can we reproduce some result or some feature, like with Hamilton, because if you follow Git practices, then it's very easy to kind of go back in time. And then otherwise, because it's in a repository, that's also, you can either build and publish Python libraries to share things, or you can just share the repository itself and get reused that way. So in terms of testimonials, just in case you don't believe me that the data scientists really love it. And so Danielle, like one of the things I remember asking her was like, when I was kind of coming up with slides for this talk, is, what do you like about Hamilton? And so she was saying, the encapsulation of logic in a single named function makes adding node edges simple to understand, communicate, and transfer knowledge. So, hence why, I think from a collaboration perspective, Hamilton kind of helps, since, with pull requests and onboarding, it makes it easier. In terms of, Shelley, another team member, she kind of likes how easy and breezy it is to add new nodes and edges to the DAG, since when the business evolves or changes, they need to kind of update and adapt. And so, which case, if a new marketing push comes in, they need to forecast that and potential impacts. Adding that new feature takes on the order of minutes, not hours, like it used to like it did before. So in terms of, just to summarize, like the impact of Hamilton at Stitch Fix. So just with using Hamilton, the Fed team gained, testable code always, a place for documentation, a data flow, the ability to visualize what was actually happening so people could understand things, faster debug cycles, and a better onboarding collaboration experience with this kind of central feature definition store as a byproduct. And so in short, that's why I kind of say this was a home run for them, because if you took Hamilton away, that'd be, kicking and screaming. But one kind of rhetorical question I kind of just want to position is that in my experience, as code bases get larger, so the more things you add to it, it's actually generally kind of expected that, the team slows down just because there's more stuff to manage and more complexity that kind of arises, right? But I want to say with Hamilton, actually, I want to say, that's not true, because actually when the project started, like they only were managing like 1,000 something features and struggling. But now they manage over 4,000 features, right? Just in the time since using Hamilton onwards. So they've added quite, more than double the amount of transforms they kind of manage in the code base. And that hasn't had any detrimental impact to the productivity. So I want to say, rhetorical question, could you keep adding to your code base, and could you maintain the same speed? Cool. So what can you do with Hamilton? Okay, so talked about it. So just to give you a bit of sense of, the things you could do. So, how to use it within an ETL system. How do you potentially reuse feature definitions for offline and online kind of machine learning use cases? Can you scale Hamilton to beyond data from a single machine? What can you exactly model? And then also, you can actually add runtime data quality checks. So as I mentioned, Hamilton is a micro framework. So essentially the only thing you need to kind of run with an ETL system is that you just need a place that runs, Python 3.6 at least. And so essentially most orchestration systems, they are kind of Python based, or if you're in the Python world, you're likely using them. And so you can run Hamilton within them today. So specifically in terms of the recipe is, if you're getting into Hamilton, so one is you got to write these functions that define your data flow, and you got to write some driver code to kind of orchestrate it. In terms of software engineering best practices, you either want to check this stuff into a repository or publish some Python packages, right? You need to include SF Hamilton as a Python dependency in your system, and then you would have like one step in your ETL essentially just execute the driver code that you want, and that's really all that's required. In terms of, I don't know how advanced everyone else is, but eventually with machine learning, you probably, you're operating in an offline context, but then maybe you then, want to have a web API that's serving, some model result, but you need to transform some features for input. So with Hamilton, because you're forced to kind of curate things into modules, one thing that you can do is you can actually, it's not that difficult to support two different ways of getting data, but sharing the same kind of, core feature transform logic. And so the way that you kind of set that up with Hamilton is that you would essentially write some Python functions that represent, where to get data for offline, and then a different module that encapsulates where to get data for online. And then they can both share the same kind of feature transform module. So if I want to, then run, if I'm then running a job in an offline context, I would then kind of write a driver script that would instantiate the DAG just from, these sets of modules. And then, the code will just work and you'll kind of, operate in an offline context. And then if I was in an online context, I would instantiate a different driver that would instantiate, rather than taking the offline loading module, it would, pick the online one, since the online one would have the logic to know, to go to a feature store or to something like that. But yeah, that's, I guess, one of the nice things that helps you set up is actually, sharing core transform logic, but then being able to kind of maybe swap out, some part of the data flow easily. With data these days, it's very likely, you don't have everything to fit on your machine. So, does Hamilton kind of support scaling that? And I want to say, yes, we do. We have some pretty, I'll say basic support, but we essentially enable you to scale beyond your laptop with kind of integrations on Dask, Ray, and, Pandas on Spark. There is a modem project that you can actually use with Hamilton today, but we're actually thinking of how can we actually add better support. But the nice thing in terms of what to scale to use these frameworks, you only really need to change the driver code. You don't actually rewrite your transform logic. For most cases, you probably don't. So it makes it easy to kind of switch backends. But the only caveat here is that, if you're looking for parallelization, if you have small data, I want to say the serialization cost might not be, worth the switch, but if you have bigger data, then they likely are. So specifically in terms of, just want to hammer home, like the changes required to go from running on your machine to say a Dask cluster or array cluster. The idea is this transform logic is the same. But the only thing you need to change is in the driver code. So here I'm kind of highlighting, you just need to add a few more lines of code and tell the driver. And so when the driver walks the DAG, what essentially it's going to do is it's going to instead delegate to either Ray or Dask. In this case, it's Dask. And so I guess that's a nice thing in terms of, I think, code reuse and maintainability. So if someone needs to really maintain different contexts, it's all kind of encapsulated in this driver class, JavaScript. The fourth thing is, just want to hammer home, as I said before, it's not just for pandas. You can model any data flow. So, pandas, scikit-learn models, NumPy matrices. There's other open source projects that are doing things with Python. You can use them. So that IBIS being one of them. Or if you want to create your own custom Python object, or even if you want to, connect with a database and run some SQL, Hamilton doesn't stop you from writing that code today. And so one of the nice things, though, just if you are doing any of this, is that with Hamilton you get lineage kind of for free just because of the nature of how you define things. I haven't shown this, but we have with functions you can actually attach extra metadata. So if you wanted to build a structure that says what team owns what's something, or does this information, does this data have PII, you can kind of annotate functions to indicate that they expect that data and kind of operate over it. And so then we haven't exposed much functionality for this, but in the driver object that you get from Hamilton, you can ask questions of the DAG that's created. So what is downstream of birth date is a question you can kind of encode into Hamilton and then kind of ask. But otherwise, if you have ideas, would love contributions here. We are an open source project. And And then in terms of just, I guess, a high-level overview, so if you're wanting to do Hamilton for feature transforms for model building, the common pattern that we see people doing is, you split things into, as I kind of mentioned before, the offline and online, is that you basically write functions or a set of modules that handle where to get data from. And then you curate your modules, sort of marketing span, client features, etc., into other modules. And then you have basically stitched the right things together at the right point with different drivers. So you might have one for one that runs in production. You might have a more debugging or plotting one to help you kind of explore things. And then Hamilton isn't opinionated in terms of where data is loaded or saved from. It's still kind of up to you. And so that is kind of after you run the driver script, that's kind of commonly where we see people go, okay, I'll save that to my data warehouse, or I'll save it to a file. You can do more advanced things. So you can do kind of most machine learning functions are generally map operations, but you can kind of model other operations. You just need to think about them a little bit more. So specifically, if you're going to be grouping by things that change an index, you kind of probably want to group them into their own module, or for more advanced use cases. Otherwise, you can also chain drivers together in the same script. Some people like to do that just for just thinking about what's materialized so that they can save the intermediate state. One thing that's kind of, I guess, a hot topic of late is data quality. Since with machine learning, one of the kind of things that you have a set of assumptions that you train a model on. If you go, run some predictions somewhere, you generally want those same assumptions to hold. So with Hamilton, we have a very lightweight way that you can kind of add runtime data quality checks. You don't have to spin up great expectations or some other kind of data quality system. Instead, with Hamilton, we can kind of I think want to be shift left in the extreme, in that you can actually we have the ability to actually annotate a function with a set of expectations. And it's pretty lightweight in that we don't store state, and the only two behaviors we have right now is that you can either log a warning or just stop execution right up. But it's a good way to also then, if someone's reading the code and wanting to maintain, to actually encode the expectations that you think things should operate on production, and then with Hamilton you can actually enforce them. So hopefully, without telling you, you can probably read that this function has pet outputs. Likely it looks like an integer type, and so with the check output, we're saying it should be an integer. The values should be between 0 and 1, and there shouldn't be any NaND values. And if any of these are false, then we should actually fail computation. For those of you who are familiar or want to do more with pandas or do something a little bit more complex, Hamilton also supports Pandera. So Pandera is another open source library that is, if you're want to do schema kind of based checks against data frames or series, like Pandera has a lot of kind of adoption, a lot of functionality there. And so in which case Hamilton also supports you expressing what you need in a Pandera schema. So this is rather than using Hamilton's kind of inbuilt, you can also kind of express it in Pandera's way of doing so. So in terms of the last 10 minutes or so, feature roadmap. So one is, we are an open source project. So if you have ideas or issues, we're actually pretty, would love to hear them. So do come reach out to us on Slack. Do file issues on GitHub. Even, we'd like to understand your use cases too, obviously, because then we can help inform as to part of the roadmap what we do. But we're super open to submissions, since I do think Hamilton is pretty pretty well defined for what it does. But in terms of where areas that it's a little rough around the edges, like this is where we need user feedback to get better. For some of you, in case you're into high performance computing, there are frameworks that essentially, if you annotate a Python function with a decorator, they will kind of help, under the hood, compile the code to make it easier or better to run for, GPUs or other systems, and kind of make Python code run at, C or Fortran-like speeds. And so one of the ideas we had is essentially with Hamilton, any framework that you need to decorate a function with, we can actually inject. And so number being one of them, the idea being that, hey, you don't have to go annotate all your transform functions with what number kind of gets you what to do. Instead, at runtime, we can kind of do that for you and kind of make it easy for you to just integrate without having to do much. And so that's kind of the idea with that. The other is kind of better SQL support. So you currently can write functions that go to a database. You need to pass in, say, the connection object and manage that. You also need to manage, figure out how you want to manage the SQL. Do you manage it in files that then you load in, or you do have strings, etc. So we're trying to think, can we make that even simpler to maintain and manage? And so, for example, how can we make it easier from a platform perspective to manage, who's connecting to what, such rather than that having being embedded too much in your code. There is if you're unfamiliar with DBT, that is something, I guess, in the analytics space that is kind of pretty hot. You can almost say that Hamilton is the DBT analog, but for Python, whereas DBT is helping manage SQL. So they just recently released some Python support, better Python support. So maybe how can we better integrate Hamilton with that? And then there's another, I guess, something that's pretty hot these days is called DuckDB, which is kind of a SQLite, but for analytics. So can we better, integrate with that to make that experience better with Hamilton? Otherwise, in terms of, I mentioned the Hamilton scales onto Dask and Ray, and it kind of Spark, but I want to say, we still consider those APIs a little experimental. And so, since we released them, we haven't actually changed the API, but we actually, want a little bit more feedback to hear, who's using it, is it working for you? If not, such that we can kind of, actually graduate the support. So that's kind of something on the roadmap would love to kind of close out at some point. But otherwise, there's many more issues on GitHub. Do have a look. Feel free to react emoji on the ones that you like, so that can help us prioritize. But otherwise, to kind of conclude most of the talk, and I'll get to your question, Shreya, in a bit. Essentially, with Hamilton, the idea is we force people to write these kind of declarative functions where the name of the function means something and the input arguments declare its dependencies. And so we use that as a way for you to describe data flows. And so, and I say it's a new paradigm because I don't know anyone that kind of does it. And it grew out of the need to tame a feature code base. I'm pretty sure if you go ahead and use it, it will make yours look better too. And so, as I kind of described with what happened at Stitch Fix, I think the Hamilton paradigm can provide teams with multiple productivity improvements and can help you scale with you and your code base as it grows. And so again, so thanks for listening. Pip and source if Hamilton gets started. If you like Hamilton, would love a star on GitHub. Otherwise, would love more, thoughts, community issues, etc. Else, feel free to join us on Slack. And with that, happy to take questions. And I'll start with, okay, Shreya. So in terms of how do you think about Hamilton, would you say it has some parallels with DBT in terms of what it enables for end users, modular, doc generation, the recommended CT way of writing models and making PIs easy? So in terms of structurally, I think, or conceptually, structurally, what DBT, I haven't used DBT extensively, but in terms of what DBT did for SQL and that it helped a team who had SQL file sprawl organize the SQL files in a way such that it was then easy to have dependencies between things, write documentation and test it. I want to say yes, with Hamilton, with Python transform functions, we get people to write things in a very structured way that helps them manage and wrangle kind of the amount that grows. And along the way, we have a very nice unit testing, integration testing, and documentation story. So if you're familiar with on the documentation side, if you're familiar with an open source framework like Sphinx, it's actually pretty reasonable to kind of take your Hamilton code and then publish it with Sphinx, such that you also have a visual front end for documentation as well. But yeah, otherwise, more questions?
Well, first, Stefan, I want to say thank you so much for going through. In fact, as you were speaking, I was like, well, what's next for Hamilton? And then you basically answered my question. Or some of the things that I was thinking about is where can I find the docs? And I actually did link off from your GitHub repository, and I'll put the link in because I think your documentation on Gitbooks is really, really good. I mean, I think you go through a lot of really good examples, and it's super easy to follow. But one question that I had is is there ever a case where you can get in some sort of an infinite loop where you're looping back on itself with the DAG?
So we have a check for circular dependencies. So in terms of kind of execution, like either you'll get a stack recursion error in terms of the graph doesn't actually resolve the path what's required, or in the cases that we can resolve it, we'll say, hey, you got a circular dependency. We can't compute things. In terms of, like Hamilton really tries to focus on, making the DAG pretty static for execution. So I didn't go through it here, but if you have if-else statements in your feature code, rather than having if-else statements within a function that kind of change its behavior based on some configuration, with Hamilton you can actually write them as those different cases as different functions, and we have a nice little simple annotation at the top of a function that will kind of dynamically, given the config when you construct the DAG, choose which function to actually include. So then that makes the process of debugging, testing, upkeep also much simpler, since it's very easy to kind of segment based on different conditions what functions are in, or what logic is in and what's not, what's out. I think I answered that question. In terms of I guess there's a follow-up from Shreya. So DBT did recently announce support for Python. So you can, if you are running DBT, you can use Hamilton within its Python functionality as kind of one way that you can manage and orchestrate. So you could do your SQL transforms, pull in the raw data, use Hamilton to kind of transform that for input to your model, or even model the model fitting process as well, and then everything there is then unit testable. I think because my one criticism of DBT's Python stuff is it's not going to help you write better Python code. It's mainly just a way to help you run Python code within their SQL ecosystem.
Okay, makes sense. Thank you.
Do you have any idea of the number of projects this could be working on at all? I mean, do you have any feedback on how much is being used in the wild?
Yeah, I mean, I really only know the people who come in for help. So I don't know. I know there's telemetry on docs usage. So the amount of docs usage I get doesn't equate to the amount of Slack users we have. And so in terms of, I see that as a good sign, as like maybe, we have good docs and people don't need help. But in terms of, I think, we've had a bunch of consultants like it, just because it's easy for them to kind of come in, provide a project and know they can hand it off with people who can understand and maintain and manage it. So in which case I know that, British Cycling is using Hamilton in production. I think the UK government digital services as well as using Hamilton in production. Stitch Fix obviously is. I think there's a few people, I guess, in machine learning type companies who are using it for their offline feature workflows. And I know lately we actually had some time series forecasters come in. So I think there's some people from who are looking at Hamilton and trying to integrate it with some Department of Energy kind of projects, since they do kind of time series forecasting, and similarly some people doing financial modeling as well.
Yeah, cool. And I guess I got another question is you kept talking about the Fed group. I guess what is that in particular? Or maybe I missed.
Oh yeah, so they're called the Forecasting Estimation Demand Team, and so businesses that have operations. So you have some sort of you need to predict your labor, you need to predict your inventory, you need to predict kind of a few things that have, so you can kind of understand in terms of the business how much staff you need or how much stock you need. That they were kind of in that role, which was like, hey, given the how much client demand are we going to get, such that we know therefore to tell how much inventory should we have, and then also how many stylists or how many warehouse workers should we have. So then the business can make those decisions to know how to staff up, and so that's kind of pretty key role in the business in terms of helping to run and operationalize it. And so but otherwise, yeah, there are a lot of, I want to say, I guess the people who are doing any time series forecasting definitely gravitate towards Hamilton just because of its roots. But otherwise, yeah, if you're not doing time series forecasting, you want to use Hamilton and you're successful, would love to hear those stories as well.
Nice. If anyone else has any other questions, I guess feel free to unmute yourself or write them in the chat.
I mean, question. So who here likes writing unit tests? No.
I don't know if I can put any hands up, I guess, if anyone can.
so in terms of, I mean, one of the ideas, I guess, on the roadmap would also be, well, if you write your Hamilton functions, like actually it's pretty conceivable to auto-generate those test stubs for you. So we could even make, the process of creating unit tests actually pretty, a little simpler. I need to write an issue for that, but like, I guess I guess I'm trying to do some product discovery here. And so in which case, if I could make unit testing easier on you, would that be, something interesting?
Personally, I think so. And I guess the other thing that I had just kind of taken a note of as you were speaking was the idea of calling functions really abstracts the functionality that's going on inside of it. So you can change the underlying infrastructure or change those functions and not have to muck with all the people that are calling it. That's one of the beautiful things I think of what you built here.
Yeah, you can be pretty surgical about it. And so, yeah, that's one of the, I guess, the nice things. I think there's, the Fed team, for instance, like they have different function implementations based on different behavior, and they have them in different modules. So it's actually very easy for them to kind of, collaborate and understand what's going on. And so precisely because of, like everything's abstracted into functions. So if they really want to replace some logic or try some new version or something, they just need to, create a new module that has those same named functions. And then when they construct the DAG, switch those functions for the ones, that were there previously. And that's one way they can test and kind of operate as well.
Yeah, I mean, it lends itself to good object-oriented design, right? You can override.
I mean, it's like, it's in this weird space where it's like functional because it's getting you to write functions, but in some sense, it is kind of object oriented in a sense that it's like, well, you just got to, it's like the name. If you have a different implementation but has the same name and the same output, then you can kind of replace it in another DAG.
Yeah.
Yeah.
Well, very cool.
Oh yeah, I guess, so the other mention, so we do have docs on how to iterate in a notebook. So if you're a Jupyter notebook person, you can, I guess, actually do things in a single script. We have a little helper function that can help you kind of inline define Python functions and run a driver script in a same Jupyter notebook if that's the way that you develop. It's the module is aptly named ad hoc utils. So if you're putting ad hoc utils into production, it's not my fault if things go wrong. But otherwise, we also have looking for ways that we can make it easier for people to onboard as well. So if you want to translate some pandas code, would be curious to hear to you, because I do think it's not unreasonable to also go from some pandas script and generate Hamilton code for you, such that then it's easier to maintain. But obviously everything's prioritized just by community involvement. So if you want to do raise your hand.
Well, good. Yeah. How many contributors do you have?
So we had, I guess, a handful of small contributors who've been doing. So one person added Docker instructions on how to run the examples in Docker if you didn't have a Python environment set up or didn't want to kind of manage it. And so I'm like, yes, yay for open source. I didn't have time to do it, but they went ahead and did it, and so super thankful to them. And then another, we have an experienced contributor who's contributed to many open source projects, helping us kind of set up and kind of run and kind of make it easier to ensure that other people who want to get started contribute can do so. And so super thankful to him to doing it. And so but otherwise, had people come in and create issues, and so we've, gives me motivation to create new stuff when people are asking for things, and if I can help, I will.
Yeah. Well, this is, as you were talking, I was like, oh, it'd be nice to have a visual representation of this DAG, and then all of a sudden, ta-da! You said, here it is, right? You can basically make one call and you can get it. Have you guys been thinking at all about the flip of that? Like, could you then drag the DAG around and it would essentially write code for you behind the scenes? You know what I mean?
That to me almost sounds like a, like would people pay for that product type question? I think, I mean, to me, I think conceptually, I view the world as in terms of DAGs. So in terms of nodes and edges, in which case, like, to me, logically, then it means, like, couldn't you define a user experience where it's like, well, if you want to change something, you just got to add a node, or you want to, like, oh, I want to update this one, you double clicking on it type thing.
Yeah.
So yeah, definitely something that I want to explore.
Okay. You're already on it. All right. I thought I had a new idea.
No, I love it. I love it. I mean, like, it's just validation that I'm not crazy.
Okay. Yeah. I mean, a lot of people are looking at low code and no code tooling right these days. So
yeah, I mean, I think, part of the reason why I think Hamilton's successful, I think, is, or at least why it continues to get usage, is that you don't need a senior software engineer to tell you to write code, because it forces you, like, your function really can only output one thing. So therefore that limits really the logic that you can put in it. And so then it really forces you to kind of chunk and grok it. And so in which case, that's easier to manage, but then it's also easier for someone junior just to, like, how do you structure their thinking, right? Well, you got to write a function at a time that does this one thing. So in which case, then that also lends itself to, like, I think, it's not quite low code, because you can do anything you want to do in Python, but it's constraining in a way that forces you to write, something that's not too complex, I think.
yeah, and I think especially for junior engineers, it teaches them best practices.
Yeah, without necessarily having that person on the pull request tell them to do so. I mean, I think, yeah, there's a few things you could do to help that. So for instance, with each pull request, have a unit test coverage metric or something, which Hamilton actually makes it easy to kind of do. And then but yeah, otherwise, I mean, that's one of the reasons why I'm excited, or at least help the team at Stitchfix, is because they didn't have the extensive software engineering background experience, but with Hamilton, like, it forces these natural behaviors, in which case they didn't have to have that experience, because the paradigm kind of taught them to do it in the first place.
Yeah, good idea. Good idea. Well, cool, Stefan. I appreciate the time. I appreciate you working on open source projects. I know it's a kind of a labor of love, right, to do all this sort of stuff. But the community thanks you for it, and it's obviously you're meeting new people and bringing in other people to work on the stuff. So obviously it's a project you're passionate about. But I find this very interesting, and I appreciate you coming to our group here and speaking on it tonight.
Oh, thank you for having me. And otherwise, yeah, if you want to connect on Twitter or LinkedIn, or more than happy to.
All right. Well, thank you everyone for attending tonight. We'll be back first Thursday of December, on December 1st. I posted a link in there that we'll be talking about what was the messages that I had in here. I guess we're going to be talking about hybrid intelligence, advancing human creativity through AI and the metaverse. So Neil Sahota is going to be the presenter that month, and hopefully you'll come back. And again, thank you, Stefan. You have a good night, and we'll be in touch.
Awesome. Thanks, everyone. Bye.